you have all the other stamps for that week, you get number 30 for free. Okay? And I have not finished grades yet for the triad, so I think your homework went in. I know second periods hasn't yet. Alright. So we're going to extend what we know a little bit about trig today. And I think one of these questions popped up in your study guide, and we kind of went through it, and then I'd made sure it wasn't on the test. So, Ivan, do we have our notes out ready to go? Because I've started.
No, Miss Bell.
Let's go. Alright, so we're going to talk about evaluating trig functions at any angle rather than just a specific angle that could possibly be on the unit circle, okay? So we can really do this with any point that they give us. Alright, so, same stuff we've been working with over and over again, right? This is just your Pythagorean theorem. Oop, that was a really bad underline. That's just your Pythagorean theorem, right? Because if I would have r squared equals x squared plus y squared, okay? So it's basically saying no matter where I put that point, I can still apply sine, cosine, tangent, secant, cotangent, okay? The x value is typically in the horizontal direction, and the y value is typically in the vertical direction, okay? The theta we would be looking at would be kind of our reference angle theta, okay? Because, well, we'll see why here in a few minutes. Alright, so we're going to determine the exact value of the 6 trig functions of the angle. So what we're going to do is to go ahead and draw a triangle in there. That's the easiest way to deal with this. Okay. And technically the length of that leg of the triangle would be -3. Because we now put it on a graph, so now it has a direction. Okay, so that's why I can put the negative on it. And then what would the y value be?
4.
It's still 4, okay? If I used my Pythagorean theorem, what is that still going to make the hypotenuse? 3, 4, 5. Okay, it's a 3, 4, 5. If I didn't know that, I could use the good old Pythagorean theorem to figure that out. Okay? So now, again, it's a reference triangle. Okay? So you're going to use that reference angle that's down there near the origin as your angle of reference. Okay? So that's going to be the angle that indicates for your sine, cosine, and tangent. Okay? So, sine of theta. We're still using good old SOHCAHTOA. So what is the opposite and what's the hypotenuse? 4 over 5. Good. Cosecant's really easy to get from that. What's your cosecant? 5 over 4. Good. The cosine of that angle is what? -3 over 5. Okay. The secant of that angle would then be? Good. Does it make sense that cosine and secant are negative in that quadrant? Isn't it all students take calculus, right? So S is the only thing that's positive. So sine and cosecant are positive. Everything else should turn out negative. Okay? All right. What about tangent? What's the tangent of that triangle? 5? 4 over -3. Good. And then what does that make the cotangent? -3 over 4. Okay. All right. The next one's similar, except that it's not a pretty right triangle. It makes it a little uglier. And they didn't give me the triangle graphed. I have to do that myself. Okay? When it says determine the exact values, that means I'm not using any decimal points, so I need to use a rational of some kind, so some kind of a fraction. So I'm going to go ahead and plot what I've got. So it says that we are out 2 and down 3. So there's my technically the angle they're looking at is probably that one, but we're going to use this one in here as my reference angle. I'm going to draw my triangle. What is the horizontal value on my triangle here? It's positive 2, right? What about the vertical? There's your negative 3. In order to get the hypotenuse, I need to use the Pythagorean theorem. It isn't a pretty one, okay? It's not a triple. So, what are my two legs? 2 and negative 3, good. And my hypotenuse, I'm just going to call x for now. What's 2 squared? 4. What's negative 3 squared? 9. What is 4 plus 9? 13, and we take the square root of both sides, so we know that this value here on the hypotenuse is the square root of 13. Now we're going to do the same thing we've done before. Okay, sine, cosine, tangent, and then their reciprocals. So, looking at that triangle, what is the reciprocal of, what is the sine of that triangle? Negative 3 over 13, right? The hypotenuse. All right, before I rationalize, what is the cosecant? Good, and it has to be negative, right? Quadrant 4, sine and cosecant are negative. All right, I'm going to rationalize to finish that one off because you know your answers will show up rationalized. All right, the cosine is what? Okay, it's 2 over square root of 13. I like that. Before I rationalize, which I got a rationalized answer, and that's fine. We're good at rationalizing in our heads. I like that. All right, what is the secant? Over 2. And it should be positive, right? We're quadrant 4, cosine's positive in quadrant 4. All right. We had rationalized it, so 2 square root of 13 over 13. It doesn't matter what's in that radical, right? Thank you. It can always get rationalized, right? It could be a smiley face in there and you should be able to rationalize it. Okay. All right, then we need the tangent of that angle. So what's the tangent? Negative 3 over 2, which makes the cotangent what? Negative 2 over 3. And again, it makes sense that it's negative because we're in quadrant 4 and tangent's negative in quadrant 4. Okay? All right. So they give us this nice little chart here. Is that somewhere typed in there for you nicely? Yeah. It's another way for you to start thinking about things, okay? It really isn't any different than what we've already talked about. We know that all are positive here, right? Sine and cosecant are positive there. Sorry, yeah, cosecant. And then tangent and cotangent are positive there, and cosine and secant are positive in quadrant 4, okay? This is another way to think about it and look at it as far as the coordinates are concerned. Remember that your x-coordinate is your cosine and your y-coordinate is your sine, okay? So what this is saying here is the cosine's positive and the sine's positive. This one would say that the cosine is negative and the sine is positive, okay? So, because it's saying greater than, remember, is positive, less than is negative. This is saying that both the cosine and the sine are negative. This one is saying that the cosine is positive and the sine is negative. Okay. So, what we're going to do in the next few, all right, is we're going to just try to figure out what quadrant they're talking about. Okay? So, it's saying they want us to figure out the quadrant where the sine is, what does greater than 0 mean? Positive, and the cosine less than 0 means negative. Okay, so here's how I think about that. All students take calculus. Okay? Which quadrants is the sine positive in? First and second, right? Everybody's positive in the first. Out of those two quadrants, which quadrant is the cosine negative in? The second quadrant, right? So the answer is quadrant 2. Not a ton of work to show, okay? I use the little all students take calculus to show my thinking, okay? All right, let's try this one. So I've got my all students take calculus. All right. Which quadrant is the do they want the secant to be positive or negative? Negative. Okay, so which two quadrants is the secant negative in? Second and third. What do they want the tangent to be, positive or negative? Positive. So which quadrant out of those two is the tangent positive in? Third. So we're looking at quadrant 3. Okay. So we know that with the unit circle that we have more than one answer for things. Okay. So, because if I hadn't put these restrictions on it, I could have had multiple answers, okay? So they're going to try to limit our answers a little bit for us. They're going to tell us that we are explicitly in quadrant 3, okay? And that's only where our answers are going to come out of. We have to figure out the 6 trig functions. They've already given us sine. What do we get for free? Cosecant. What's the cosecant of theta here? Negative 3 over 2. All right, I'm going to draw my picture. Okay, I'm going to make sure it comes out in quadrant 3. Okay, so remember this is the opposite and the hypotenuse. If I think about my triangle here, my triangle, if I drew a triangle in quadrant 3, it would look like that because it has to touch an axis. The opposite is 2 and the hypotenuse is 3. Where is my negative going to go? What would make sense? Is the look at the, I want you to go back and look at these first two that we did. Look at the hypotenuse there. Is it positive or negative? Positive, right? What about the hypotenuse on this one? Is it positive or negative? The hypotenuse is always positive. So where's my negative going to go on this one? On the 2, right? And it makes sense because the 2 went down, right? Okay, now I need to figure out my other leg. So what am I going to use to figure out the other leg? Who's our friend? It's a right triangle. How do I figure out the other leg, guys? Pythagorean Theorem. Okay, so I'm going to use 2 squared for a leg, and I'm going to use x squared for a leg equals the hypotenuse squared. All right, what's 2 squared? 4. And what's 3 squared? 9. All right, move the 4 over. What do you get? 5, and we take the square root of both sides. But remember when we take a square root, isn't it technically plus or minus? In the x direction, did we go in the positive x direction or the negative x direction for that triangle? Negative, so you got to kind of be careful. The other thing you do is you make sure you have the correct sign for what quadrant you're in, okay? We know the sinus and cosecant are negative in this quadrant, okay? So I also know the cosine is negative in that quadrant, so my cosine answer should come out negative. All right, so let's go for it. Let's find the cosine. So what's the cosine of that triangle? Good. Did I get a negative cosine like I was expecting? Yes. Okay. All right, what would the secant of that triangle be? Negative 3 over square root of 5, and then we go to rationalize, so negative 3 square root of 5 over 5. Good. All right. What's the tangent of that triangle? Negative 2 over... Double negative is going to go. Does that make sense for tangent in quadrant 3? Yeah, all students take, right? So t is positive. All right, before I rationalize, what do I get when I flip? Why did I write square root of 3? I don't know. That's a 5. Typo. All right, square root of 5 over 2, and then I'm going to come back here and rationalize this guy. So 2 square root of 5 over 5. All right. They're not going to give us an explicit quadrant the next time. We have to figure it out. So we're going to put what we did in examples 3 and 4 together with what we did in example 5, all in example 6 here. Okay? All right. So first of all, I need to know what quadrant I'm in. Okay? So this cosine value, even though it doesn't explicitly state it, isn't it positive? So which quadrants is cosine positive in? 1 and 4. Okay, so I know I'm in one of those two quadrants. What is it saying about the tangent? I'm negative. So out of quadrant 1 and 4, which one are we in? So we are in quadrant 4. So I'm going to draw my triangle down here in quadrant 4. All right, I know I've scribbled in there. I'm going to get rid of my scribbles. Okay. So we know that cosine is what over what in SOHCAHTOA world? Adjacent over hypotenuse. This would be my reference angle. So my adjacent is on the x, so that's 3, and my hypotenuse is the diagonal, that's 5. What does my other leg have to be? 4. But be careful. Notice it's coming in the downward direction. What do I want to put on that 4? A negative. So you see, the only thing we've changed is now we're kind of placing that triangle in there and giving it a location, so we have to worry about whether one of the legs is positive or negative. Okay? All right, so, easily from cosine I should have gotten secant, right? What's your secant? 5 over 3. Okay. The sine is what? Is it just 4 over 5? Watch your sign. It should be negative, and that makes sense for quadrant 4, right? Sine is negative in quadrant 4. All right, what about the secant? Negative 5 over 4, I like it. Good. All right, the tangent of that triangle is what? Negative 4 over 3, right? Opposite over adjacent. And again, tangent should be negative in quadrant 4. All right, cotangent is what then? Negative 3 over 4. Okay. You felt like you got the test wrong?
Yeah, because of secant and cosecant. I think I switched.
Oh, you think you switched them? Oh, what did I do here? I didn't write that right, did I?
No.
It should be that. Sorry.
Yeah.
I'm having issues today. You should see me last period. I couldn't take a derivative to save my life last period. Okay. All right. So we've got the term. This one's weird. Okay. The terminal side of theta lies in the given line on a specific quadrant. Find the values of the 6 trig functions of theta by finding the point on the line. Okay. So it says that we're in quadrant 3. It basically gave us an equation of a line. So let's graph that line. Okay. I'm going to give us some points here, some values here. All right. So technically my y-intercept is 0, right? And I've got a slope of up 1 over 2. But I could also go down 1 over 2, couldn't I? So there's the line that they're talking about. But what they want me to do is they want me to get the triangle based off of that line. But which quadrant do they want my triangle to lie in? 3. So I'm drawing the triangle associated with it in quadrant 3. We're going to put our theta in there. And then we get to label our legs. So let's find the length of each one of the legs. What's the length of this horizontal leg?
2.
Is it just 2? You got to put the direction in there. We went negative on that one. Okay. What about the vertical leg? Negative 1. Good. And now I need to find the hypotenuse. How do we find the hypotenuse? Pythagorean Theorem. So negative 1 squared plus negative 2 squared equals x squared. So what's 1 squared?
1.
2, negative 2 squared? 4. So x squared is equal to 5, and we're going to take the square root of both sides, right? So it's square root of 5. All right, here's what I want you to do. I want you to try to find the 6 trig ratios from there. So I'm going to give everybody about a minute or so, maybe a minute and a half, to find all 6 right now. Okay. You ready? Sine, cosine, tangent, cosecant, secant, cotangent. Okay. Alright, so of that triangle, what'd you get for sine? Okay, negative 1 over square root of 5, which we had negative square root of 5 there, right? And most of you went to this. Negative square root of 5 over 5. Everybody okay with that?
Yeah.
Alright, what was the cosine?
2 square root of 5.
Okay, so you started with this, right? We flipped it for this. And then you rationalized it. So negative 2 square root of 5 over 5. Alright, what's the tangent? 1 over 2. The double negative went positive. What did that make the cotangent? 2. Okay? We kind of changed the way we present it, but it's the same old stuff over and over again, right? You should be getting really good at your 6 trig ratios. Alright, here comes your unit circle. You ready for it? Hopefully you've got your unit circle out. Okay? It says that we're going to evaluate the trig function of the quadrant angle. This is something we've done before. Okay? So if I get out my good old unit circle here, I know that this one is pi over 2. I know this one is pi. I know this one is 3 pi over 2, right? That coordinate there should be out 0, up 1, out negative 1, up 0, and out 0, down 1. Okay, so sine of pi. Remember, it's cosine, comma what? Sine. All right, so what is the sine of pi based on our unit circle? 0. All right, cotangent is what over what? Cosine over sine. Good. You have to know that to use your unit circle, right? It doesn't work without knowing that. All right, what is 3 pi over 2? What's your cosine? 0. What's your sine? Good. And so my answer is 0. All right. Secant is the reciprocal of what? So it's 1 over cosine. All right, so what's the cosine at pi over 2? 0. So what do we write down for this one? Undefined. Okay. All right. The next piece is something I gotta show you. We don't use it a ton because of the way I teach it, but I need you to know that it exists. Do you have to fill in there? Yes? Okay, so I'm going to give you a minute to fill in what you need to fill in. And then I'll talk about it. Okay, so here's how I bridge the gap of what I've shown you to what they're wanting us to do here, okay? When I first showed you unit circle, we did triangles, right? And we color-coded the lines, and we had a reference triangle, right? So our reference triangle was either 30, 60, or 45, okay? What that reference triangle does is basically it tells us what this gap is in here, or in here, or in here. Okay, and the problem is we might not always have 30, 60, or 45 as our reference triangle or our reference, what they're going to call reference angle. Okay, so we have to be able to figure out what that is, and then I can use my trig to solve things if I have to. Okay, so if I have one that lands in quadrant 2, all right, we know that quadrant 2 is pi or 180 degrees. So in order to get that reference angle, okay, we would take 180 or pi and subtract our angle. All right. This one here, in order to get this reference angle, see how we have a giant angle and then we have this that's 180 in there? You would subtract. So you subtract the big angle minus this angle right here, the 180. Okay, so it's a little bit backwards. This one here goes almost a whole revolution, right? And we know a whole revolution is either 2 pi or 360. So to get the reference angle in quadrant 4, I subtract 2 pi or 360 and I subtract the angle. Okay? So we're going to practice a few of these. Most of them are in radians either in degrees or pies. There is one that's just in radians, so we have to deal with that. And I'll show you how to deal with that. All right. So 300 is going to land you in which quadrant? 4, right? It's going to land you somewhere here. And for me, it helps me to draw the picture to visualize how I'm going to, what's left to get. Okay? So I need to get that little chunk in there. All right? How am I going to find that reference angle? Subtract from 360, right? So what's 360 minus 300? 60. And you see that little mark? That is what we could, they're using that to stand for the reference angle. They use that little prime symbol to stand for that, okay? In the process of doing the problem, I already sketched theta and theta prime, didn't I? Because that was theta and this was theta prime, okay? All right, let's look at the next one. So this one says I have to go negative 135 degrees. So remember, that means I'm going to go in the opposite direction, right? Which quadrant is that going to land me in? It's going to land you over in 3. So I'm going to be, this is my theta, right? My negative 135. Okay, I have to find this piece right here. That's my reference angle. How am I going to do that? What do you think I should do there? Because I didn't really tell you what to do with it when it was negative. What's my overall, if I looked at, because somebody just gave me the answer. If I looked at going from here to here, how many degrees is that? 180, right? So wouldn't I do 180 and subtract that 135 that's there? So what's my reference angle? $45 degrees. All right, I want you to take a minute and look at your unit circle with me. Find where negative 135 would be on the unit circle. Look at quadrant 2. Look at where the pink angle or the red angle in quadrant 2, right? It's on the red line, isn't it? Okay, what triangle is your reference triangle there? The 45. So see, didn't we get that same number pop out there? Okay, it's connected. But unfortunately, it won't always be one that's on the unit circle. Speaking of that, here's one that isn't on the unit circle, right? So which quadrant is 323 going to land you in? It's going to land us somewhere here in the 4th, right? And I don't expect perfection on this picture. There's your theta. This would be the reference theta, right? Theta prime. All right, so how am I going to figure that out? What am I going to have to do? Subtract from 360. So 360 minus 323 ends up being what? So 37 degrees would be our reference angle. Meaning if I had to do some trig, I could use my sine, cosine, tangent with 37 degrees when we've calculated with those things before using our calculator. All right, looking at the next one. Okay, this was something... we talked about this for the test last week. Is that in radians or degrees? Radians. Why is it in radians? No degree symbol, right? Okay, now let's talk about this in radians and decimal point radians. Okay? We know that this is 0 radians. This is pi, isn't it? What's pi in decimal? 3.14 is enough. Okay, I know, it's up there. I want to make sure you know what it is. Okay? So, which quadrant do you think 2.3 is going to land in? It's probably going to land over here in 2, because it's probably bigger than the 90, right? But it's probably not quite 3.14. So this right here is your 2.3. That's your theta. Okay? We need to still figure out reference theta. How do you think I'm going to do that in decimal point in radians? How much is it from here to here in decimal? 3.14, right? So I'm going to do the same concept. I'm going to do 3.14 and I'm going to subtract the number they gave me, 2.3. What did we end up with? 0.84 is the reference angle there. Okay. All right, that's it for today. It should keep going.
Yes,
No,
we got
because
it.
that's enough. My brain has handled enough. Okay. I will come around and stamp. Here's what I did. So Wednesday and Thursday is supposed to be a performance task. Okay. We have to do the performance task before we can enter section 4.5 because it's kind of a preview of 4.5. You do some discovery again. Okay. So what I'm doing is I'm not adding additional homework on top of that. I took today's homework and split it into 2, and I'm going to take tomorrow's homework and split it into 2. That doesn't mean don't do all of it tonight. You should do it tonight, right? So because you get your questions answered tomorrow. Okay? You guys are going to work on performance task Wednesday and Thursday. We're going to start it Wednesday together. I'm not going to be here Thursday. Okay? I have to be at a breakfast thing on Thursday for Senior Student of the Month. Okay? So you guys are going to be kind of on your own, but hopefully you'll have most of it. You'll understand what to do, and you'll be able to answer the questions in class on Thursday. Okay? All right, I'm going to come around and stamp. Remember, you get 30 for free if you did the other 4, right?